Okay, 2016, question 1, probability. Paper 2. It says a survey of 168 people was carried out. Participants were asked whether they owned a cat or a dog, and the results were recorded in the Venn diagram. Of those surveyed, 19 people didn't own either a cat or a dog, and complete the diagram. So in the Venn diagram here, it has in 64 in the overlap between cats and dogs. So that's people who liked cats and dogs. It had 48 in just having a dog, so they didn't have a cat. But in the text, it said 19. So that 19 has to go in the rectangle outside your two circles. Okay? So the next part, it wants you to complete the rest of the diagram. So we need to fill something into this box. So for this box, you need to know how many you've got left. So if we add up the numbers, if we add 64, 48 and 19, so 64 and 48 and 19, when we add them all up, you get 131. So far we've got 131 people used. We had 168, so you go 168, take away 131, which means we were missing 37 people. So 37 people had a cat but did not have a dog. Okay, then it asks you, a person is chosen at random from those surveyed. What's the probability they own both a cat and a dog? So both a cat and a dog is the overlap part. So you write down 64. But again, 64. 64 is bigger than 1. So that's not the probability. So your probability is 64 over the whole survey. So the whole survey was 168. So you'd have 64 divided by 168. Part 3, it asks what percentage of people surveyed owned one animal only, and give your answer correct to one decimal place. So our people who owned a cat was 37. Our people who owned a dog was 48. So you've got 37 plus 48, which gives you 85 people owned one animal only. We want the percentage of the people surveyed. So you're putting 85 over the total amount surveyed, and because we wanted the percentage, you were multiplying it by 100. So you're going 85 divided by 168, and you get 0.505, etc. And then multiply that by 100. So we are getting 50.595%. And you wanted to correct to one decimal place, so you're looking at this, the second decimal place, so you're getting 50.6%, okay, as a percentage who owned one animal only. The next part says Mandy wants to buy a ticket to go to the theatre. She can choose a ticket for a balcony or stalls. She can go on a Monday, a Wednesday or a Friday. And for an extra charge, she can have a VIP where she can meet the band, or she can choose an ordinary one. All right, to complete the tree diagram below, and hence or otherwise find the probability that Mandy chooses a VIP ticket on a Wednesday. So in terms of filling it out, you had a balcony or a stall, you had a Monday, a Wednesday and a Friday. So on your Monday, you had the VIP or the ordinary. On Wednesday, you also have a VIP or ordinary. Friday, VIP, ordinary. So then we go Monday, Wednesday, Friday, VIP, ordinary, V in ordinary, and V in ordinary. So that's completing our tree diagram. But we want probabilities. So in terms of probabilities, for here we only have two choices. So the probabilities for each of those choices is equal, so it's a half. The next step up, your probabilities are a third. And the next branch out again, you're back to 2, so it's a half again. Right, so because these are not all the same probability, they're not all a half or they're not all a third, you cannot just count the end leaves as your answers. Okay, so fill them all in. And the question is, we want to know that she chose a VIP ticket on a Wednesday. So she could have got a VIP ticket on a Wednesday by going this route. So she went B, W, V. So she went up here out here, and up this one. So the probabilities to go that route were a half, followed by a third, followed by a half. So that was one of her options. Or she could have got a VIP ticket going along this branch, which is your stall, your Wednesday, and your VIP, which is your half, your Wednesday, and your VIP. So you are going to multiply these out because you had to do each of the three. So you had to do a half, and you had to do the third, and you had to do the half. So when you multiply that out, if you multiply the top by the top by the top, you're getting 1. Multiply the bottom by the bottom by the bottom, you're getting a 12th. Same for this one. Right? So in terms of her options, she could do this or this. So you're adding those two probabilities together. So you're getting 2 twelfths or 1/6. And that is the probability. Okay. In terms of working it out as well, if you looked at your end branches, counted, you've got 2 of them, and you've got 2 out of 12. Okay, that was that question.